OpenAI, Anthropic, and Google would write a blank check to anyone who can solve a specific 5-year-old flaw in their systems. Right now, millions of users are attempting to pile impossible amounts of information onto a framework that eventually shatters the logic of the machine. The standard approach feels intuitive. To help an AI understand a complex project, you upload everything. You feed ChatGPT or Claude massive PDFs and dozens of instructions, assuming a bigger dataset produces a smarter output. The reality is that as the volume of information increases, the system's ability to logic through it often begins to decrease. We can see this in the context window. Tech companies market how it holds millions of words. They prove it with the needle in a haystack test. The AI extracts one buried sentence by matching patterns. But finding a word isn't reasoning. Passing a search test creates a false sense of security. It masks the fact that the AI may still struggle to comprehend how those millions of data points actually relate to one another. When we move away from those controlled tests and into messy, real-world tasks, the performance starts to shift. This graph illustrates context rot. As the data volume on the bottom axis moves to the right, we see a sharp drop in the quality of the AI's logic. If you ask a model to analyze a 50-page report and draw a nuanced conclusion, it begins to hallucinate connections or offer contradictory answers. Engineers have traced this specific type of failure to a phenomenon they call the lost-in-the-middle problem. In this diagram of a long document, the AI shows high retention for data at the very beginning and the end of the prompt, but the vast majority of the center effectively blurs, becoming corrupted or ignored by the processing engine. Providing a comprehensive document can actually make the AI's processing less reliable, turning a wealth of information into a processing liability. This isn't a mistake in the code that a developer can fix by writing a new patch. The issue lies in the foundational engine of modern AI, the transformer architecture. The limitation is built into the math of how these models calculate relationships between different words simultaneously. As this network expands, the architecture struggles to maintain the integrity of those connections. The more context added, the more internal links degrade. Adding raw computing power doesn't stop the failing connections. The structural strain remains. The same architecture that allows AI to be fast and fluent is the same architecture that forces a trade-off between the amount of data and the quality of the reasoning. Since companies can't easily change the math of the transformer, they are creating tools to help manage these symptoms. This is Retrieval Augmented Generation, or RAG. It keeps your data pool separate from the AI, using a filter to find and feed only the specific sliver of information needed for a single task. Developers are also looking toward 2026, when recursive language models may offer a way to move past these current bottlenecks. But for the tools we use today, the burden of data management falls on the user. We have to move away from treating the AI as an infinite library and start using it with precision. Mastering these systems requires identifying the specific essentials the AI needs, rather than drowning the prompt in every available document.